Welcome to RNG Girls, a podcast on the people, projects and politics of renewable natural gas. I'm Lisa Kitt, founder of RNG Girls and managing director of Dahlia Recruitment. Our podcast aims to bring you the latest insights in the RNG market by sitting down with the key players who are shaping the industry, from operators and developers to investors and policy leaders. Joining me as my co-host is the brilliant Skye Austin. She's the sales director for StarkTech's RNG and compression division and co-vice chair of American Biogas Council. Together, we'll explore what's being built, what's being funded, and what it really takes to deliver projects in the real world. Please stay tuned for our regular episodes, and let's keep pushing the boundaries of what's possible in renewable natural gas. Hello, welcome back to the RNG Girls podcast, where we talk with the people sharing the future of biogas and renewable natural gas. I'm Lisa Kitt. I'm the founder of Dahlia Recruitment, where I connect the biogas industry's top talent.
And I'm Skye Austin with StarkTech, where we engineer and fabricate gas upgrading systems from creation to pipeline. I also serve as co-vice chair of the American Biogas Council. I feel like this is the conversation that we probably should have started with. When you live in the industry daily, it's so easy to assume that everyone understands what you're talking about.
But what's interesting, the more people understand this space, the more they tend to support it. It's not a pushback problem, it's about understanding the problem. So this is Biogas 101, no background required. Paul, glad you're here.
Thank you very much, Lisa. I appreciate it. It's wonderful to be here.
So before we get into the technical side, how did you even end up in biogas? Because this is not exactly a straight line kind of career.
Sure. So early days, I started out using my chemical engineer degree in the wastewater world, doing clean water, dirty water, and biogas became a part of that. A lot of that started, say, working with municipalities at their wastewater plants. Thousands of them have their own digesters. And from there, I wound up working for a couple of different EPC companies as a project builder. We did a lot of work for food and beverage clients where we were doing digesters at cheese factories or wineries. And eventually I became a developer where we were doing design, build, own, operate digester projects, learned all about project finance. But 2010 was kind of a pivot point for me where the ABC got started, and I was the first founding member of that. And so I could tell that this was going to be a growing space. So I always said to myself, I felt like I would enjoy being a national leader, someone with a national view of what's working well, what's not working well, who's doing well, and then just getting to know all the projects, right, to learn what projects are succeeding, what are struggling, and how to take a new project and benchmark it against something that's already working. So yeah, that's how I got here.
It's quite a common theme in this industry, I find. People don't exactly plan for it, but they find their way into it. I mean, you founded Biogas TV, which is obviously something that's really helping people know about these projects. The people and the technology actually work in the real world.
Yeah, Biogas TV is a good time. The death of print media has grown opportunities for YouTube, for video, storytelling, messaging. So Biogas TV episode 1 was a field project case study. And that's where I thought we would succeed the most, would be to go to job sites, tell the story of the project, talk to the owner, look at the equipment. Hey, how's it work? And we found that there's a little bit of reluctance from some people to show their equipment. Sometimes things are a little proprietary, and some people like to keep a lower profile. And deploying to a project site is very involved. It can be expensive to get people there. You get a film crew and all that. So we reassessed and decided on doing a recorded desktop setting where we can do things quick and free. And so now we're telling the stories. We've settled on every Monday at 12 Eastern time to provide a half an hour of value to all the listeners, to which we get about 90 every week that come biogas industry insiders to learn from experts, talk about new trends, So it's been an awakening to become a YouTuber and understand all that's involved with that and all the metrics and all the likes and the clicks.
Mhm.
And but it's been a good time. People are very much validating the need for biogas TV. So the future looks bright, and we're having a good time along the way.
Are you getting any listeners from kind of UK and Europe at all, or can you not tell the demographic?
Do have a lot of following from global people, a lot from India, a lot from Pakistan,
Mhm.
Brazil, Argentina, Singapore, Malaysia. Even though kind of what my pay job is very US focused, I do get a global audience for sure.
Right. Well, once you've got this podcast out, maybe we can drive you some more traffic globally.
It's all good. I have fun. Like I was on a call the other day with a guy from Pakistan who wanted to talk to me so much. He said, I have this biogas business and we build digesters at people's homes and we take the cow dung and we use it for the cooking gas. I'm like, that is such a
Mhm.
cool story. I'm not sure what my place is in this conversation about building home-based digesters in
Yeah.
Pakistan, but regardless, it's wonderful to meet you and thanks for reaching out.
That's so interesting. I mean, I know your goal and your reach is to share the stories behind the scenes of the industry, but like it extends past biogas TV. I know I am very passionate about the kind of people that are drawn to this industry, and in my opinion, they're the best working group of professionals that I've ever been able to work with. So I feel very lucky on a daily basis, and that seems to be an opinion that you share as well. Can you tell me a little bit more about the giants of biogas and your new highlight to the pioneers of the industry?
Sure. Yeah, definitely, as you've picked up, a common thread among us is passion for what we do. And people truly, their hearts are in this work. And so the Giants of Biogas was started in that, for whatever reason, as an industry, we've kind of shied away from awards. And everybody likes to be acknowledged when they're doing good work. For a while, there was some project awards. It's increasingly rare to have rewards for individuals. And so, as we're gathering in Detroit on May 20th, a part of what I do every big conference is throw a big party. And so this year's theme we chose was Giants of Biogas. So we've had a nomination process where I kind of put it out to the greater community. We're going to do these awards. We are awarding based on innovation, ability to deploy capital, openness, thought leadership, safety, environmental stewardship. And we got about a dozen strong nominees. And then the judge panel, we felt, why not do more, right? Rather than giving one or two, we saw the 10 winners this year were just really solid people that have passion for the industry, that have made it their calling, and all of them, their hearts are all in. And so we just decided, yeah, let's give out 10 awards to these people, and we're calling them giants, and we're throwing a party around it. So it seems to be getting validated as a worthy effort, right? Who knows how long this notion of the giants of biogas may go on? It may be a short-term thing, but um, as a concept, validating the special people in the industry is A, fun, B, appreciated, and we're having a good time with it.
I love that. No, it should be a great time. So let's break down the things that people outside of the industry need to know. So, Paul, if someone hears biogas for the first time, what would you tell them?
Of course, it's the result of the biological decomposition of organic matter. That's kind of the clinical story. Quickly, a smirk kind of comes on our face because we're humble people. We know that this is maybe not the most glamorous story where you talk about cow manure or food scraps, and we none of us take ourselves too seriously in the space. But yes, we're taking things that are biodegradable and organic, putting them into this sealed tank with mixers and covers and heaters, And as a result of that, we're getting a gas that's a mix of biomethane and CO2, to which we can make energy from that. We can make fertilizer and compost from that. So it's a circle of life kind of story where I'll say, listen, we are right at the middle of sustainable ag, waste recycling, sustainable energy, economic growth. And people say, oh, well, I'm into all of that. Tell me more. So that's how the
So,
first conversation goes anyway. That's how my wife reminds me of what the businesses I'm doing. She says, remember all these great things that you're doing. Like, oh, it's not just, taking cow manure samples at a cow barn. It's cool.
yeah, it's way simpler than what people think, right?
I mean, when you go to a project and you see what's before you I think some of the designs are elegant.
Mhm.
Sometimes you wind up in facilities that, okay, you're managing waste. Some facilities are cleaner than others. I had the luxury of going to a project in Pennsylvania last week where they said, Biogas TV, come take a movie of our facility. And it was shiny, it was new, it was just built, and they had these beautiful stainless shiny digesters, and everything was pretty and shiny. I said, oh, we build like exotic, beautiful equipment. It's all shiny and stainless. And give it a couple of years, it might not look quite so pretty.
So this is where people usually check out when you start talking anaerobic digestion. How do you explain that in a way that people can actually visualize?
I feel like the key to our story is we're more environmentally friendly than fracked gas, fossil gas. So we start to talk about the methane that we've avoided through some of the practices people are using now, like big lagoons, big ponds. Isn't this digester tank a more elegant look than this big lagoon that's over here that's bubbling methane? And people say, oh, this tank looks like a much better approach. And so, our challenge as an industry is commonly we embrace the connection between biogas and natural gas and say, hey, they're just the same. But I'll push back on that and say we need to promote the differences, because let's say I'm in the shipping business and I know I can fuel my boat with liquefied natural gas, LNG from frac sources for $1. If they go to pure liquefied biogas, they have to pay $4 for that, because it's more expensive for us to build a digester than for a gas driller to pop a hole in the ground and natural gas comes out. And so the carbon friendliness of anaerobic digestion is really the key story, because we're not going to succeed just selling a molecule against the molecules, because people say a methane molecule is the same from either. And we have to say, yeah, but ours is better.
Ours is dual purpose, right? It's not just a molecule of energy.
It has a mitigation function and purpose.
So when I think about digestion, I remember doing my first, well, you say the smirks and that, people get all the funny comments and stuff. I remember doing my first dairy digester project, and I've never heard so many poop jokes in a boardroom before.
Right.
So we are all 10-year-olds at heart, or 2.5-year-olds, because my grandson is really, really into those kind of jokes. But I will tell you, in a corporate boardroom, the same kind of jokes come out when you are trying to combine 7,000 cows worth of dairy manure. Anyways, when I think about a digester, the way someone explained it to me was it's kind of like a cow's stomach. And I'm sure that there's a more eloquent way to explain the actual process of digestion. So, Paul, how would you explain it? Because obviously we're taking these things in, we're putting them into the digester, but what happens to actually create that gas?
Yeah, it's a 4-step chemical process that uses different enzymatic and biological action to take big carbon molecules, you break them down, and you make acids out of them. And then eventually, the methanogen is a type of bacteria that takes in the acids and it makes methane and CO2. So between enzymes and bacteria, it's a 4-step chemical process, some of which happens quickly, some of it takes a long time. And one of our limitations is that the system does take a while to do that work. It, we can build digesters at anywhere from 2 to 5 weeks of residence time. The material sits there to undergo its full transformation. And the systems are fairly large, right? I joke that if you take like a cup of waste, that's as much material as you can feed into about a cubic foot of digester space. So a cup into a cubic foot, that's what it can handle every day. And so you just got to make sure you don't overfeed it, because it is a living, breathing organism, the digester, and any living, breathing organism can be upset if it's overfed, or not work well if it's underfed. So that's where we as engineers come in and just say, this is based on what you have for incoming waste, and we will size it for 3 weeks of residence time, adding about a cup of waste per cubic foot per day. And from our experience, we know that, like every dairy farm, one milking cow, the waste that she makes every day, that's going to make us 100 cubic feet of biogas. So we've been doing this for a while. We have rules of thumb. Every pound of food waste we collect from a grocery store, we put that into a digester. That's going to make us 2 cubic feet of biogas.
So nothing really goes to waste. It just changes form.
That's right. We enjoy the fruits of the labor there, the biomethane as an energy source. The nutrients that come out are valued as a fertilizer product that we can put back on the land to grow crops. And it is kind of a total recycle, zero waste type of technology.
So you've got energy on one side and then something useful back into the soil on the other.
That's right. So we're in the waste recycling, sustainable ag, and the waste space, and the economic space, job space. Lots of solutions are brought by this one concept of anaerobic digestion.
Right. And when we say waste, what are we really talking about?
So I think different cultures, different geographies look at different waste a little differently. So some farms will look at things like corn stover or rice straw, rice hulls as a feedstock for digester. Some others will spread that on the land for its nutrient value. An interesting concept is a bit of a hot topic in the industry, this thing of diversion of waste. So some markets have diversion mandates where, let's say in New York City now, if you're a restaurant, you used to be able to just take anything, put it in the garbage bag, and they would send that away, and that would get buried. That landfill gas would make renewable natural gas. But in some places like New York City, there's diversion mandates now that say, no, listen, you need to send that excess food from what you're doing. You can't put it in the trash anymore. You need to either go to composting or you need to go to anaerobic digestion now. And so, great question, Lisa, that a waste to some is a resource for others.
So this is broader than what people think. So it's beyond agriculture and food and even wastewater, and extends into something that you pointed to a little bit. We all contribute to, and that's the landfill. So, Paul, can you explain how landfill gas capture differs to active digestion in a digester?
Yeah. So the digester is a sealed tank, and the ability of the digester to capture resulting methane is highly efficient, and 95+% ability to keep the methane enclosed and sent away for fuel use. Burying organics in a landfill, certainly landfills are mandated now to extract the biomethane. An engineered digester will get you, say, 60 to 70% methane. a landfill where you have to pull on it with a vacuum system that sometimes will pull air in with it as you're drawing off of that landfill. So landfill gas is trickier to clean than digester gas because you do get some of that air in there and your methane levels are lower, maybe, 30 to 40%. But certainly, many landfills are making a go of it, taking all that methane and making it to pipeline quality RNG. But digesters tend to be just a more efficient way to create methane and to further monetize it.
So landfills at their core are just, having waste go through its natural cycle and then capturing it and putting it to use if you're turning it into, either biogas to electric or biogas to RNG and injecting into the system.
Yeah. And digesters are what happen when you intervene and actively control the process then.
You're touching on a very fascinating bit of a hot button for the industry where, landfills have been declared to earn in the US this D3 RIN status, which automatically gets it a preferred price to a food waste digester. So the government policy actually is driving the behavior of pushing waste more to the landfill, which you would think it would be the opposite. It would try to divert from landfill, but the fact that the landfill does earn the D3 RIN and the food waste digester gets the cheaper D5 RIN incentivizes people to push waste into landfill, which is a bit of a hot topic, prickly topic, if you will.
That's one of those things that, we could talk policy for a while, but I think this is what happens when federal and state policy is not in lockstep and align. We're pushing with one hand and pulling with the other. So you're not incentivizing in the same way from state to federal, and I think that's the rub, so to speak, and being able to have food waste qualified in the same way that a landfill is, and therefore not incentivizing the action that the state is trying to push. So it's always an interesting conundrum. So now that we've explained how to create all of this gas, at what point does it actually become something that we can use?
Yeah, coming out of the digester, you have enough energy in there to fuel an engine. That was common in early days, 10, 20, 30 years ago, where, 60% methane will sustain a flame. And so we can go into a reciprocating engine and make electricity out of it. A lot of the early projects I worked on, you would take the raw biogas, you would dry it, and you would send it into a boiler of a big cheese plant or a big brewery. Every big brewery has a big digester in the backyard, and they take that biogas and they send it back inside their facility to provide process heat to the factory. So yeah, once you get over 50%, you're able to find opportunities to monetize that gas and put it to good use.
So we're cleaning it up to match natural gas.
The molecules will match natural gas. We're trying to talk about the differences between biogas and natural gas is how much better it is, but you're absolutely right. The molecule is the same. It's the CH4 molecule. So bio RNG, bio LNG is the same as fossil LNG on a molecule basis. Absolutely.
And I think that's the real game changer. It's not a substitute for traditional natural gas. It's simply an alternative that's completely interchangeable, but it's like it has a plus one because it has an environmental attribute or benefit to it that far extends traditional natural gas. And every project type has a different value to it, but it's a really interesting way to bring identical fuel onto infrastructure that provides additional value.
So America, we're told that we're energy independent. So, we're making LNG, but yet we're shipping this LNG overseas. We're in the midst of this mess in the Middle East now over liquid petrol, just, oil as we've always known it. So one of my stories I'm working on these days is more CNG fueled vehicles, right? So if diesel's stuck at $6.50 a gallon now and natural gas is still cheap, It's about $45 an MMBTU to fuel a truck with liquid diesel. So $45. But for half of that, let's say $20, everybody's happy if you're doing like a CNG truck that's maybe half RNG and half CNG. Your carbon footprint is much less, and you've saved half, right? So find me a business that wouldn't enjoy saying, instead of $6.50 a gallon for diesel, I can show you dramatic cost savings of, I'm going to charge you half of that. And yes, you do need to convert to maybe a dual fueled vehicle, CNG and liquid fuel. But I find that our political attention span in this country is about like 15 minutes long. And if we thought about it, take this notion that America's energy independent and this idea of maybe doing more biomethane fueled vehicles makes a lot of sense.
Which makes it a lot more practical than people think.
Yeah, I mean, because we're not really rebuilding infrastructure to deploy this. We're using primarily, outside of additional CNG stations, we're using what's already there. We're just making it more reliable, ecologically friendly, and right now, with everything going on, a heck of a lot cheaper. And we're utilizing the existing natural gas infrastructure that we already have.
Why does that matter right now?
It's again our lack of attention span. We're a bunch of ADHD kids here that we live in 15-minute blocks of time. If I were to say, what's sound energy policy looking out 3 to 5 years, it would be, don't be so reliant on other countries for liquid petrol. We have all this natural gas. We are awash in natural gas in this country. The idea of us selling our LNG to Asia, I find a little bit insane. If we are truly energy independent, why don't we use some of this, more of this natural gas to use ourselves, especially if it's cheaper than these other sources of oil?
Yeah, and I think that's like most of the time, this isn't an industry support problem. It's really an industry understanding problem because people just don't understand how we can fit in and how we can actually fit in better.
Oh.
And
Agreed.
I think, you've touched on it a little bit with your beginning conversation about energy security. But I think you can dive a little bit deeper into really how that fits in, because this isn't like a weather dependent, intermittable type of resource. It's something that's a firm capacity resource that we're able to generate here in the US.
I think we hear a lot about energy security. Where does this fit?
Yeah, it's American, it's MAGA, it's jobs, and the challenge is the price. So properly acknowledging the low carbon intensity score is part of what all of us at the ABC struggle to do. I'll joke to myself, when I get out of bed in the morning, my job is to try to sell $4 gas for $25. So how do we do that today? And it's all about environmental friendliness. It's all about CI. And as much as we're getting excited about things like new IMO regulations, we still have a tall hill to climb, because Carnival cruise ships can buy cheap LNG to fuel their ships and find some environmental benefits. But to get them off of that over to RNG, bio LNG for 4 times the cost, intuitively, that's a pretty challenging question to answer, but we have the answer, and we just need to rally behind getting this story articulated and for it to be valued, right? So as we're starting to look at fueling ships now, we've done the trucks. We're excited about fueling ships and boats. Oh, ships, boats, and planes. Those industries haven't bought biomethane before, and so now having them understand why they should buy bio LNG versus straight up LNG there's still a lot of work left to do.
I mean, I think that it's an interesting story because, we talk about how it's more expensive and properly understanding the value behind it. But I think one of the values that we undersell when we talk about it is that this is an uninterruptible supply. This is firm capacity. And there's a lot of this industry that, you can actually balance cost by utilizing firm capacity in its best state. So like this is just another option to be able to utilize utilize molecules of energy that way, whether you're looking at electricity or you're looking at RNG. And so this is just, one of those, the waste doesn't stop, so the energy doesn't stop kind of scenarios.
Mhm.
And you touched on it a little bit, but like, where are you really seeing the demand show up now?
We try to stay close to as many exciting stories of people that want our low CI RNG as we can. And so such things as Canada are popping up, which is curious, right? We've had some recent political kerfuffles with Canada, but their CFR program has people's attention. The reality of that is kind of yet to be proven out, but their carbon credits are trading for over like $400 a ton. And so the idea of us selling our RNG up north of the border is strong. There is a crisis in RNG offtake these days. We've been holding out hope that, say, some of the corporate multinational 100s would be touting or valuing decarbonizing more than they have, like the Vanguard project at AstraZeneca in Virginia. We thought that model was going to take off and say, yes, AstraZeneca, we want to help you decarbonize. This is a way to do it. I'm starting to hear more from the data center world about there's a lot of problems with siting a data center. And sometimes, we're hearing about building mini nuclear or big natural gas fired peaker plants to fuel the data centers. But, biomethane certainly is a better story. And yes, you could also drive your data center with other renewables, but maybe driving some of these data centers can be an all the above approach, but their appetite for energy, it kind of looks like it's a 10x over what we can effectively deploy to a typical huge data center. So I think vehicle fuel has strong promise. The end user does need to value the low CI properties. They know, okay, you've won me over. I need to get away from liquid diesel and go to CNG because the economics there are slam dunk. Oh, but wait a minute, you want me to slip some RNG in there as well? That's 4 times the cost of conventional CNG. Help me with that math. Why should I do that? Well, you're fueling Amazon trucks, and Amazon has said they want to decarbonize. So ever since 1st of January 2025, I think the industry has felt some level of slowdown in that some of the value of the work we do has been devalued, right? So, we see it every day at the ABC where people in government agencies actively don't want you to talk about carbon mitigation. That's something that they've said isn't the value to us. If you want to talk about jobs or talk about some other story, talk to us. But the value of decarbonizing has been lessened in recent years.
I think it's interesting, like from a political standpoint. I know when I was in DC not long ago, one of the things that really, popped people's eyes open was when we did talk about how you can take biogas and turn it into electricity. I mean, everyone's feeling this data center kind of, I guess, push or urgency, so to speak. And they have an increasing demand on the grid. They have no tolerance for downtime. And there are states doing things like passing widespread moratoriums on development. But you're also seeing states pass, other gas banning, provisions as well. So like states banning natural gas appliances in new homes. So the demand for a solution on the electric side just continues to ramp up. And I think when we talk about its Swiss Army knife, Heather on our policy team talks about it constantly, like RNG is a Swiss Army knife, or biogas is a Swiss Army knife. We can turn it into many different things, including electricity. That seems to gain some traction right now.
I hear that, and certainly we all love the biogas to electricity story. It was our story solely 10, 20 years ago. It's what we did. We need somebody to really push that agenda. The electric generator suppliers used to need more work, and so they would be very active in advocating for policies favorable to electric generation, but they are so busy these days selling power gen equipment, burning natural gas. So the electric generator people are neutral whether their fuel source is CNG or RNG. To them, it's the same. So we need people to push that, right? So it's part of this boom in data centers has meant that there's some parts of the supply chain where you're waiting 12 months for your component. And so it is a boom currently because of the data centers, because of the increase in need for electricity. And that supply chain has been enjoying the fruits of that. But pushing the biogas to electricity story is one that we just kind of got to look around each other and say, okay, who's gonna lead this story?
Well, hopefully we're starting that today. at least starting the conversation to let people know that it's an option, right? Like everyone used to know it was an option. And I think it fell out of favor thinking about it as an option. So we have to continue to talk about it, and we have to continue to talk about it loudly. So we tend to try to wrap things up with some rapid fire questions. I'll let Lisa kick it off.
What's the biggest misconception about biogas?
Well, the odor factor, the ick factor tends to come up, and it's incumbent on us as good facility builders to be a good neighbor. There's many plants running that run safely, that are good neighbors, and we need to keep touting that story because, yes, an RNG facility in your neighborhood can be a good neighbor. It can be an answer to waste recycling. It can be a provider of jobs. And so, have there been issues in the past with some of the kind of ick factor, smell factor? Yes, but telling the story about being a good neighbor is one thing that's incumbent on all of us to keep doing.
And what's one thing that people underestimate?
Well, the amount of time it takes to get a project built. Are you talking about people in the industry or people we're trying to educate? But, people say, yeah, I want to be running a year from now. Well, we've all been around projects that, oh, wait a minute, you're 3 years into this, you're 6 years into this, you're 10 years into this. It's quite something to be a part of the journey where to get engineering done and siting done and financing done and permitting done. Unfortunately, these jobs take a long time to get cranking.
Yeah, what's one of the things the industry gets wrong about itself?
I do think we need to talk about the safety story and put in a commercial for the operator school. There's a lot of rotating equipment. There's a lot of, converting packaged waste into energy. There's a lot of moving parts along the way, and openly just telling the story about safety, making sure the operators go home at night in the condition that they were in when they got to the factory. Sometimes there's gases that come from this that can be hazardous, things like H2S. Just being realistic with ourselves on not glossing over the safety question.
And if you were to use one word about this industry to describe where we are right now, what would it be?
I would say heart. So I use that word because it's been a soft year. Those people still standing in the space have passion and conviction for it. That's why we're still here, because we believe in it and we're having fun doing it. So that would be my answer to your question.
Oh, that's a nice one. Well, look, we've talked a lot today, and you've really explained things so well. So thank you for that. And we've loved having you on, Paul. But what's the one thing that you hope that people take away from this podcast today?
So one thing I'm working on is legacy, right? So I'm at that stage in my career where, I'm talking about leaving a legacy. And I tried to retire last holiday season, and it was so heartening that people said, "No, don't. We like having you around." And so keep telling me you like having me around, and I'll stick around.
I love that.
I
So
don't think you're going anywhere soon, Paul, from what I can
yeah,
gather.
we certainly don't hope so. We want you to stay around for a lot longer. So
Happy
I
to
think
be
it's
here.
clear that this is a really interesting industry resource, and it's kind of been here all along. And thank you so much for helping us try to tell more about the story and to continue to get support to turn waste into critical energy resources and get people to develop it. So thank you.
Yeah, you're welcome. Thanks for having me
Thank
on.
you
I
so
appreciate
much.
it.